Hey guys, this video will be over classifications of matter. So matter can be classified into two separate categories. The first one is a pure substance, and the other one is mixtures. So what's the difference between a pure substance and a mixture? Could you really tell the difference? By looking at it, probably not. Maybe, but probably not. A mixture can be defined as something that can be separated by a physical change. So let me write it down here. Now, what does that mean? That means that we could separate it by melting, or by boiling, or freezing, or by picking it out by hand, right? So then there's also two different types of mixtures that we have. We have a heterogeneous mixture, and then we also have a homogeneous mixture. And some examples of heterogeneous mixtures are soil. They are also concrete. We also have Chex Mix. Oops, too used to writing mixture. Okay, so then if we go back over here to homogeneous mixtures, some examples of that are going to be salt water, Kool-Aid, brass, even air is a homogeneous mixture because it has nitrogen and oxygen and helium and carbon dioxide and all these other pure substances mixed in with it. So all of these things could be separated by a physical change. We could boil off the water in the salt water, right? In the salt water, we could boil off the water. In Kool-Aid, we could boil off the water, and then we could separate the Kool-Aid from the sugar by particle size. With brass, we could melt off the different metals that were in it. With air, we could condense the different molecules in the air. Okay, so there's all sorts of different ways that we can separate these mixtures, and we're going to talk about that in just a few minutes. Before we do that, though, I want to go back and talk about pure substances. Okay, I'm not sure what happened there, but something got weird, so we're starting here again. Okay, so here we have mixtures, homogeneous mixtures, heterogeneous mixtures. They can be separated by a physical change. And now I want to talk about pure substances. So there's also two types of pure substances. So pure substances, the two types are going to be an element and a compound. All right, so elements, examples of elements are going to be things like carbon, right? Magnesium, copper. They can all be found on the periodic table. And an example of a compound is something like salt or sodium chloride. We also have lithium sulfate, or even glucose. So all of those are compounds. Now, how could you tell the difference if you were put in front of you a sample of an element or a compound, so a pure substance sample, and you were asked, is this an element or a compound? Would you be able to tell the difference between the two? And you couldn't by just looking at it. You would have to know what was in it. But if you performed a decomposition on it, you tried to do a chemical change on it, the element would not decompose, but the compound would, right? So compounds can decompose or be separated with a chemical change. So if we look at that a little closer, what I mean by that is when we look at sodium chloride, table salt, if we were to do a chemical decomposition on it, we would form sodium and chlorine. So it was sodium chloride over here, which is table salt, the salt that you put on your food. This sodium right here will react violently with water. This is chlorine gas. It's not the same thing as the chloride that's in your sodium chloride. So it is changed chemically. That is a chemical change. So next we're going to look at different ways to separate mixtures physically, right? And before I do that, I want to show you one big picture of all this. Hopefully it works. We'll see. So if I shrink this down, pull it here, and then there we go. So matter can be separated into two categories, a pure substance or a mixture. Mixtures can be separated by a physical change. So if you just boiled something, a liquid, and one thing boiled off at one temperature and then the next thing boiled off at another temperature, you would know that you had a mixture of stuff. If everything boiled at the same temperature, then it was a pure substance because it all had the same boiling point. Now, mixtures can be further categorized into two categories, a homogeneous mixture and a heterogeneous mixture. In a homogeneous mixture, all the stuff looks the same. You can only see one substance in there, but there's more than one thing there. In a heterogeneous mixture, you see more than one thing. You see maybe more than two things. So you can actually see with your own eyes that there's more than one substance there. Now the difference between an element and a compound, compounds are made up of elements that are bonded together, and they can decompose with the chemical change. Elements can't, because they're already as small as they're going to get. Here, we're going to talk about methods of physical separation for mixtures. And the first one is the simplest one. It's just simply by hand. The second one is going to be by a phase change, melting, evaporation, stuff like that. The third one is processed by using magnets. So if you have something magnetic in there, you can pull it out with a magnet. Fourth, decanting. This is where you pour off you pour off a liquid. That is on top of a solid. It's the best way I can explain it. So like if you have a beaker that has sand in it and water on top of it, you could just pour the water off of the sand. Okay, and then next we would have filtering. So you could filter a liquid off of a solid, or filter out a solid from a liquid. Number 6 would be something like centrifuge. So your sample gets spun down really, really, really fast, and then bigger molecules go to the bottom. And so they're separated by size. Sifting. Oops, forgot the T. Sifting is you can separate different sized particles by putting them in sifting pans that stack. And so the bigger particles would be left on the top and smaller particles would be on the bottom. And then another one would be distillation. So in distillation, basically what we have is we're going to have one flask. Let me move over a little bit. Okay, so we're going to have one flask down here. And another flask over here. And this is sealed off. And then this is sealed off, and there's a small hole just big enough to fit a thermometer in. So you have a solution in there, and let's say the solution is a mixture of alcohol and water. Now alcohol has a much lower a lot of alcohols have a much lower boiling point than water does. Water boils at about 100 degrees Celsius. At 100 degrees Celsius, not about, at 100 degrees Celsius. And alcohol, let's say this alcohol boils at 65 degrees Celsius. So if we heat this up, right, so I'm going to put my fire down here. All right, if we heat this flask up on this side, then what we're going to get, as soon as we get to 65 degrees, the alcohol is going to begin to boil in this flask. And so then it will start turning into a gas, and it will vaporize and go up here. Now, inside of this, right here, okay, there's two little things come out here, and we put cold water into this hole, and it circulates around, let me get my pointer, it circulates around that tube that's open to this and open over here. And then the water comes out this way. So we're constantly putting in cold water that's circulating around here and then coming out here. Well, the alcohol that's now a vapor over here will condense back down, and it will travel down this tube, and then it will come out on this side and settle over here. And so you'd end up with your alcohol over here and your water over here. And so that's what distillation is, and that's how you could separate two liquids that have different boiling points. All right. The last method that I want to talk about is a paper chromatography. All right, so with paper chromatography, all it is it's going to separate things by color. or it could separate things by whatever solvent you use. So I'm just going to talk about color right now. If I take a piece of paper, filter paper, okay, and I take a Crayola marker and I make a dot right here, and let's say that Crayola marker is purple. So let me make a purple dot. There we go, purple dot. And then I take a Sharpie and I make another dot with the Sharpie. Okay, and then I place it in water. So I've just put the tip of this paper in water. Well, the water is going to be absorbed by the paper and it's going to begin to start moving upward. And as it moves upward, the Crayola marker is going to start to move upward as well. And so what we're going to see is we're going to see a red dot, and then we're going to see a blue dot, because that's what purple is made from. Now the red ink is less soluble in the water than the blue ink. In this case, I don't know which one is which really, but in this case, the red one moved a little bit further than the blue one, or a little bit less than the blue one did. So that means the blue one liked the water way better than the red one. It was more soluble. It could dissolve easier in the water, and so it moved further up the paper. Whereas the Sharpie didn't move at all, because you can't clean Sharpie off with water. It's only going to be cleaned off with alcohol. So it's not going to dissolve in water. And so you could separate things based on what they dissolve well in using chromatography. And so it'll travel better in a solvent that it can dissolve in. All right, so that's all for this lesson. I hope that clarified some stuff, and let me know if you have any questions.